Power with an exponent as a rational number. If a is a real number and n a natural number greater than 1, we have a to the 1 over n is the nth root of a. So if you ever see like a square root, so the square root of a number is the same as that number to the 1/2. The cube root of a number is that number to the 1/3. The fourth root is that number to the 1/4. That's what we mean. So for example, 25 to the 1/2 is the square root of 25, which is 5, right? Negative 27 to the 1/3 is the cube root of negative 27. You can't take the square root of a negative, but you can take the cube root, or the fifth root, or the seventh root, any odd numbered root. So the cube root of negative 27 is negative 3. A to the 1 over n does not exist if a is negative and n is even. It exists if n is odd and a is negative, though. For example, negative 49 to the 1/2 does not exist in the real numbers. You can't take the square root of a negative, right? There's no two negative numbers that are going to multiply together to give you a negative number. There's no two positive numbers that multiply together to give you a negative number. Okay, that's why it doesn't exist. By the way, the square root of negative 1 is I, the imaginary number. Now, I is not a member of the real numbers. So this is the imaginary number, and for example, the square root of negative 49 would be 49 times negative 1, right? The square root of 49 times negative 1. We have 49 times negative 1, which is the square root of 49 times negative 1, which is the same as the square root of 49 times the square root of negative 1. And the square root of 49 is 7, and the square root of negative 1 is I, the imaginary number, so we have 7i. And that's the power with an exponent as a rational number. Have a good day.